Hello everyone, so welcome back again, and today we are going to discuss about the OSPF metric. So dear, the metric value is important because the OSPF chooses the best path on the basis of lowest metric value. So now we are going to determine the OSPF metric values for the multiple path. Then we will observe that which path will be automatically selected by the OSPF as the better path. Okay. So lowest cost is equal to the best path or better path. Okay. So this is the rule to select the best path in case of OSPF. Okay. So now, first of all, we will consider a network. Okay. Let us assume, dear, this is our network. Well, I have already configured the OSPF over here. Now we will only going to analyze the OSPF path selection procedure. Okay. So how does the path will be selected? There is something called cost of path, right? According to the rule, there are some path cost. Okay. So these are just like this. So these are the by default path cost in OSPF. So default reference bandwidth is 100 Mbps. Okay. So according to the 100 Mbps reference, there is if an interface bandwidth is 10 Mbps, then the path cost will be 10. If 100 Mbps link will be there, the path cost will be 1. Okay. If 1 Gbps will be the link, the path cost is 1. And if 10 Gbps link, then the path cost is 1. Dear, this will really create an issue if we have different bandwidth like 100 Mbps, 1 Gbps and 10 Gbps. So OSPF will consider all the bandwidth path cost 1. The same path cost will be taken as reference. Dear, first of all, we have to change this. Okay. We have to change the default bandwidth. How we can do that, dear? So we can use a command router OSPF, the process ID, auto cost reference bandwidth and 10,000. Then the reference bandwidth will be taken on the behalf of 10,000. Okay. So let's first of all put this everywhere on the router. Then we will find the best path. Okay. According to the rule. So let's go to the network. Here we have a network on which I have configured the OSPF everywhere. Now we are going to put this put this command so to change the reference bandwidth. Okay. After changing the bandwidth, after applying this configuration, the path cost will be changed. The default path cost will be changed. Like 10 Mbps link will be having a path cost of 1000. Okay. 100 Mbps link will be having a path cost of 100. 1 Gbps link will be having a path cost of 10 and 10 Gbps link will be having a path cost of 1. Now, let me go to our network and first of all apply this configuration auto cost reference bandwidth 10,000. Okay. Starting from R1. Okay. So, router OSPF 1. Okay. Auto cost reference bandwidth that is 10,000. Okay. So now it will be changed by default bandwidth on this router, but I have to apply this configuration to all the network router because if I will not change the reference bandwidth, other router will not able to distinguish that. So now let's go to router number 2 and change the reference bandwidth. Okay, so router OSPF 1 auto cost reference bandwidth 10,000. Okay. Now let's go to router number 3 and change that. So router OSPF 1 auto cost reference bandwidth that is 10,000. Okay, let's go to router number 4 and also change that. So router OSPF 1 auto cost reference bandwidth, that is 10,000. Okay. Now let's go to router number 5 and also change the reference bandwidth so that the different bandwidth could able to be distinguished by the routers. So router OSPF 1 auto cost reference bandwidth, that is 10,000. Now we have changed the bandwidth everywhere. Okay dear. Well, we have already configured the OSPF. Now let's see which path is the best path among these. We have two paths from R1 to R3 or this loopback IP. Well, we are going to ping this loopback IP. We have two paths. First path is going through R2. Okay. Another path is going through R4 from this next hop address and from this next hop addresses. Okay dear. Let's see which path will be automatically selected by the router. So let's go to router 1 and put a command to show IP route OSPF. So it will show you all the path for the OSPF. So it is showing the two different path here. Okay. So which path is this? So the best path from R1 to R3 is this one, right or not? 110.0.2.1, okay, is going through 192.168.10.2. So this will be the best path, right or not? But dear, now what I will do, I will going to disconnect some routers, okay, turn off some interfaces. Okay, so interfaces are over here. I'm going to turn off these interfaces, this interface and this interface, because this network will be automatically down. Okay. So this network will be automatically down and we could able to find the bandwidth of above one. Okay. So let's go to router number 1 now and let me turn off this interface F0/0 and this interface so that this network will be totally down to find the metric values of above path. Okay, so let's go to router number 1, interface F0/0 shutdown. Okay, next let's go to router number 3 and also going to turn off the interface. So interface F0/0 shutdown. Okay, we have turned off the interface. These, so all these routers will be disconnected. Now we have only one path, that is going from R1 R2 to R3 and the loop back. Now let's go to R1 and check the reference bandwidth. So show IP route, do show IP route OSPF. Okay dear, so it is showing some bandwidth. Like if you go to, if you want to go to 192.168.20.0, the total path cost will be 21. Okay. So how it will be 21 here? So when I will go to R1 to R2, so 10 will be added from here. Okay. Then 10 will be added from here. So total path cost will be 20 up to 192.168.20.0. Okay. But when we reach to 190.10.0.2.1, the reference bandwidth will be 10 plus 10 plus 1, because the loopback IP address having a high bandwidth, higher bandwidth than the gigabit. Okay. So total will be 20, sorry, path cost 10 plus path cost 10 plus 1. Total will be 21. So this is why the path cost from R1 to R3 is 21. Now let me turn on the interfaces below and we'll find the path cost of this path number 2. Okay, so I'm going to turn off these interfaces, all of them, and I'm going to turn on these only. Okay, so let's do that. Go to R1. Okay, so interface F0/0, no shutdown, and interface G3/0, no shutdown. Sorry, interface G the 3/0 shutdown. Okay, so I have shut down the interface of above side. Let's go to R3 and turn on this interface, turn off the above one. Okay, so how we can do that? Interface F0/0, no shutdown. Okay, interface G4/0, no shutdown. G4/0 shutdown. Okay, let me turn off this one. Shutdown. So what we have done here, we have turned off some interfaces. This interface is shut down now. This interface is not working. So that is means above path is no longer working. Only the path below is working. Okay, now we are going to find the path cost. Okay, dear. So let me go to R1 and put a command to show IP route OSPF. So it is showing the path cost over here. Okay, dear. So let me tell you what will be the path cost. Okay, dear. So from this router to this router, the path cost will be 100 plus 100 plus 100 plus 1. Okay, because R3 to loop back is 1. So total path cost will be 301. As you can see over here, the total path cost from router number from path number 2 is 301. Okay, so now let me again turn on all the interfaces and you will find that R1 will become the best path because it is having the lowest metric value. Okay, so interface G3/0, no shutdown. Okay, let's go to R3. Interface G3/0, no shutdown. Okay, okay, now let me put a command to show IP route OSPF. Okay, so here we can see that it is automatically have selected the path number 1. Just hold on for a while. The neighborships will be again up now and it will take a few minutes to do that. Okay, then the path 1 will be automatically selected. G3/0, no shutdown. Let's go to R3. Okay, okay. So the interface is interface G4/0, no shutdown. So when I will put this command, the interface will be up now and neighborship will be again created. And because of that, above path will be automatically selected as the best path. Okay, it will be updated within a few seconds. Okay, so just hold on for a few minutes till the neighborship will be reset. So here we can see that it has become 10.0.2.1 having a best path through 192.168.10.2, and this is the reference bandwidth or metric value, that is 110/21. So lowest is 21, that is why this path has been selected as the best path. Okay, so that is all for today. Have a nice day everyone.